Welcome in, everyone. Thank you so much for joining us. We're going to spend the next hour throwing out some cues, giving some A's as it relates to the climate model and the general state of space engine. If my panelists would like to introduce themselves.
Amir, do you want to start? I think you probably don't need any introduction here, but
well, no. Hello, everyone. I am after space engine.
Yeah.
That's yeah. I think at this point everybody probably knows who Vladimir is. So yep. He obviously he still exists. He is still doing the main author of Space Engine things, leading the creative vision of the project. He's still coding. Probably, I guess, Vladimir, you're probably coding even more than you were a couple of years ago now.
Oh, I don't know. It's hard to measure. Maybe yes.
Maybe yes. Lots of work going on behind the scenes, but yeah,
Vladimir keeps all of us in line.
That's right. Yeah, Vladimir really needs no introduction. He's the reason we're all here. I guess I'll go next. My name's Alex. Some of you have probably seen me around as Sindri. I will change my name back later. But it's in all the posts as that, so I'll keep it as Alex for the moment. I'm the CEO of Cosmographic Software. Basically responsible for, running stuff company-wise. Don't really want to go into too much detail there. I think kind of everybody's got a concept of what that job looks like. I am not a programmer. If you ask me programming questions, I will give you, or I guess my monitor, funny looks. Those are things that other folks can answer. But if you have questions about company things that are able to be answered, I will do my best. I guess that's a good enough introduction from me. Megan, want to introduce yourself?
Hello. I'm Megan. I am a programmer and science expert with Space Engine and Cosmographic Software. I have a PhD in astrophysics. My thesis was about weather on brown dwarfs and the composition of their clouds. I did a lot of spectroscopy, so looking at like the chemical breakdown of like the light that we get from brown dwarfs. I have a bachelor's degree in physics and astronomy, a master's degree in astronomy, and a PhD in astronomy. I just had my 1-year anniversary working on Space Engine, so it has been a lot of fun being here, an absolute pleasure. I really like working with the team. I really like interacting with you guys, although I apologize, I've been a little quiet on the Discord in the last couple of weeks, but there's just been a lot going on. I guess I just want to clarify that you don't, like, we're celebrating the release of the climate model, and we welcome all questions about the climate model, but if you want to ask other things, you can do that too. So let's have, a cool discussion of everything Space Engine with a focus on the climate model, I guess.
All right. Very excellent. I think that actually segues great into the first question that has been tagged here. What is the climate model? My brain can't understand what it is.
The climate model, as it is right now, we're calling this version 1 of the climate model, is a surface temperature model for planets in Space Engine. So a lot of different things impact climate in general. Climate is your temperature on your planet. If you have an atmosphere, it can involve pressures and densities, wind speeds, everything. Ultimately, I guess it kind of culminates in weather, like we see here on Earth. And there's so much that can impact it, like winds, ocean currents, the chemical composition of your atmosphere, that sort of thing. So they're really complicated. So as I mentioned, this is sort of stage 1 of the climate model, and it is mainly a temperature model. Temperature is what you need to get started on everything else to do with climate. It's a very basic model. Right now in Space Engine, when you open up the climate tab in the in-game wiki, it'll give you information about the temperature at 0 altitude. So if the planet was just a flat surface, what would the temperature be? But then it gives you information about the surface temperatures, if there's, say, mountains or like depressions, like valleys and stuff. It doesn't work inside of liquids right now, so lakes, oceans, that sort of thing. There's no temperatures inside of those, and they actually don't have any impact on the temperatures in the game right now. Because, again, this is step one, and climate is very complicated. Sorry, was that too long, or was that a good answer? I don't know what I'm doing here.
That felt good. Yeah, well, you're answering questions. That felt good to me.
It is one of the core tenets of my own education to leave questions open-ended to let the other person say kind of as much as they want to regarding the question. So I think that was a perfectly beautiful answer. Right, our next question here from Gabriel. Does Space Engine use I assume that's pronounced, Carnot heat cycle?
In the context of the climate model, no, it does not. So the model is, how do I want to say this? We use an energy transfer equation that is just very basic. It assumes a like a parcel of air moving around a planet, and how, if it behaves as a black body, which is a perfect absorber or a perfect emitter in astrophysics terms, how does the temperature of that little parcel change? So as it goes around the planet, it's getting more or less incident light from the star, and it is also radiating away heat. So we do a basic calculation using that. We don't get into any really complex thermodynamics at the moment.
Very nice, thank you. Looks like a lot of people interested in getting an answer to this next one. Let's see. Could the new climate model be used to modify the planetary surface textures and/or clouds distribution?
I'm gonna let Vladimir or Alex handle this one because I don't want to give any, spoilers.
Clouds link a climate model to clouds distribution.
Yeah, that's the
Well,
question.
Well, it's a next step, as we now have a good climate model which describes, literally speaking, temperature at any point of planet surface and in its atmosphere. We could now generate clouds and a snow level according to this data. But it's quite a big chunk of work. It will be in some next versions.
It's one of those things as well that I think we need to really be careful about giving any kind of even hint of timeline on. I'm not even willing to meme that one as soon TM, because that's something that we have to look at if it's a before or after OpenGL, right? So it's probably going to be a post OpenGL thing, because ultimately we want to make sure that things like volumetric clouds can be done in a way that's satisfying and that's worthwhile. We don't. I imagine that a lot of people in the audience can appreciate this. We don't want to do a bunch of work and put in a product that doesn't look as good as it can, right? So if all of that effort's going to go in, do we want to do it in OpenGL? It's been depreciated for like 6 years now, but it's something that we want to do, as Vladimir said. It's something that lays the groundwork for it. We don't have to do those all of those equations again. Megan put a ton of work into the behind the scenes. So yeah, to put it succinctly, I guess it is something we want to do. Is it something that will be happening very soon? No. It's something that we're going to have to take a lot of time to consider in terms of timeline and how to implement it. But something simple that Vladimir also mentioned there, the the snow, right? The snow lines. That might be a first step there. But again, we're going to have to wait and see on that.
If I could add a fun sort of science addition onto that. So the part of the question about climate model and cloud distribution. So I'm not speaking about Space Engine here, just about climates in general, and academic research regarding like cloud stuff. To determine what sort of clouds occur in a planet's atmosphere and at what altitudes and what types of clouds you're going to have, you require a pressure temperature profile. You have to know at any point in the atmosphere what is the pressure and what is the temperature. And then you can make this profile for a given planet. You can plot over top of that condensation curves for different types of molecules. That tells you at what pressures and temperature combinations will a molecule condense into a liquid or even a solid. And where the profile of the planet and the condensation curves overlap, that's where different types of clouds will occur in an atmosphere. So you can, if you have these two pieces of information, you can say, oh, I will have methane clouds, and below that I will have carbon monoxide clouds, and you know actually which order they go in. So there's a little bit of sciencey fun fact tidbit on top of that.
Thank you very much. Very thorough answer to that question, which is a good thing too, because a lot of people wanted that answered. All right, next question is short and simple. When Space Engine 1.0 is released, will the previous version be free?
I think the answer to that is no. I know that might disappoint some people. Sorry. Yeah, it's going to be as an update, right, to the current version. So that would also not be terribly practical.
Mm-hmm. So in other words, that dichotomy there is there's that obsolete free version which is out there that will never change.
Yeah, and that free version that's out there, that's what is it, 198? There was even before then. Anyway, there were a lot of questions when that initially disappeared. The best answer I can give to why that went away as well is that it had a lot of issues with it in remaining current, right? There was a lot of effort going into supporting its usability when, you know, our main version on Steam is usable and is updated and is being supported. So continuing to support an old free version is kind of difficult when we're trying to focus on development. So hopefully that also answers that question, which I suspect is probably in a lot of people's minds.
Hey, we're getting a proper list of questions here, so moving right along. Will the sea have more animations, like huge storms and the water is moving crazily?
Actually, this will require a significant update of engine.
Yeah.
Right now, everything on the planets like a fixed terrain. Clouds is also implemented as terrain internally. But when we move to volumetric clouds and volumetric water, of course, we will have animation. But this will be in future after migration.
So in short and sweet terms, that sounds like a great idea.
I'll add on to that as well that there are a lot of things that are in that boat of planned but not practical with the current engine, right? We like everyone on the team wants things like volumetric clouds and volumetric water and stuff like this. Prioritizing them and doing them in a way that is both useful and aesthetically pleasing. Those are things we have to take into account as well. So yeah, not soon TM, but planned. Planned, and actually I believe it might be on our internal roadmap already. So it's there.
All right. Up next, how does Space Engine determine the greenhouse effect heating from atmospheric composition? Might have worded that weirdly.
I'm going to let Vladimir answer that one because when I implemented the climate model, I actually didn't update anything regarding
Yeah.
greenhouse.
Well, greenhouse effect is estimated with a simple equation using a molar mass and a pressure or density of atmosphere. It's very basic. In future, we will probably upgrade this model so it could use some real atmospheric composition and a spectrum of sunlight, but I guess it's quite too complex for Space Engine right now. Space Engine is not a scientific simulation software. It does not need that exact details, I guess. But maybe in future we could add some most important cases like CO2 or water. But it's hard. It's a lot of science.
Sure. So we'll become more robust in the future, potentially. All right, moving right along. How is the emissivity coefficient of planetary surfaces calculated? Perfect black body, 1.0 bond albedo, other?
Yeah, good question. So for context, for those who aren't super familiar with these astronomy terms, albedo basically is a description of how reflective a surface is on a planet, whether that's the top of the atmosphere or if there's no atmosphere, it's just like the actual physical surface of the planet. Albedo tells you how much is sort of reflected. Emissivity is an atmosphere term. Emissivity is it's a number from 0 to 1 that represents atmospheric effects for like calculating the temperature of a planet, for example. So we determining emissivity is very dependent on the planet's atmosphere and the properties of that atmosphere. And the climate model that we have implemented in Space Engine is quite generic. We had to make some compromises in a lot of different spots to make a model that worked for everything. But in short, it's 1 minus the bond albedo.
All right, thank you.
I got a little technical. My apologies. I hope the background was helpful.
It looked like a technical question, so I think you answered perfectly in tandem. And were you about to say something, Alex?
Oh no, I'm just getting prepared because I see the next question.
Indeed. All right, next question. Are there any current plans for cast shadows?
Of course, yes.
This is another one of those things. You're gonna, with a lot of these, in particular graphical elements, you're gonna have me kind of sound like a broken record here. Unfortunately, the issue right now is that, as Vladimir kind of pointed out earlier on, there are engine limitations, right? So, when can we do this? And is it going to be worth doing in a particular time? Is this something that is OpenGL or Vulkan? Is like the question that always ends up being asked. And so, I suspect, I know that is on the not too distant roadmap, but in terms of timeline, I have a suspicion that it's going to be post Vulkan. But yeah, it's definitely not in the super distant future, though. It is something that we are definitely planning toward. And shadows in particular, I know, even amongst the team, it's something that it's like, oh my god, like we said that shadows would be out all this time ago, and then it never got implemented. So yeah, we are all acutely aware of that. It is on our radar.
And then there are two different questions about volumetric clouds, but I believe we may have already covered that somewhat.
Yeah.
Do we have any further commentary on volumetric clouds, or is it still just kind of stay tuned?
Volumetric clouds, post Vulkan. We aren't going to be able to do that properly and like in a good looking way until after we move to Vulcan. That's what I'm hearing from the programmer who's currently working on or will soon be working on migrating us to Vulcan. Is that while we could do okay looking volumetric clouds with OpenGL, waiting and doing them in a better way in Vulcan is the correct way to do it. And I'm gonna defer to his judgment on that because he has a lot of experience with Vulcan and with the differences between OpenGL and Vulcan. So yeah, that's all I'll say on that.
All right. So same as shadows, same as clouds. Stay tuned post Vulcan. All right, next question. I'm going to reword it slightly to be more open. What are the current plans regarding the Nebula editor? Would it be nice for there to be more editing and manipulation options for a given nebula?
There are no plans to work on it in the nearest future. We have a lot of over tasks.
No plans right now. Much to do. All right, moving right along. Will there be Google Earth support for the Earth model in the future? Like we could see cities and real mountains, volcanoes, and stuff like that.
No, because why? We are Space Engine. We're not a Google Earth clone. And also, I don't think that a Google elevation map and textures are what freely available.
Mm-hmm. We don't think Google Earth is very interested in making themselves obsolete.
Yeah.
All right, this next one is a more technical question. Expanding on that emissivity coefficient question, does the engine behind the scenes estimate things such as ocean hydrography surface coverage to compute the planet's visual and bond albedos, or is the terrain generation decoupled from that value?
It does not right now. It uses estimation of ocean and cloud coverage to compute atmospheric and ocean composition, but it's a different subsystem. It's not tied to climate model right now. And also, it's really hard to more or less precisely compute an average albedo of a planet because you must generate the whole planet texture with some resolution. And when integrated, it will affect the generation of the system performance a lot, but with something to consider in future.
All right. Next question. Will Space Engine ever be ported to a different operating system, such as Linux or a cut-down mobile version?
Yes, we have plans for this, for Linux and maybe Mac.
Right.
We have
plans for Linux. and
Sohu
maybe Mac.
is our resident Linux enthusiast.
Yeah.
Yeah.
You guys will know. I don't know how to pronounce his username. Vladimir, do you know how to
Semyon?
Simon's username? Yeah.
Username? I don't know.
Yeah.
I don't know.
But anyway, he's someone you have seen around before. Maybe he'll talk in chat there. There he is. So and now our resident meme lord as well. Yeah. Yes, that is something he's enthusiastic about. But there's also, from what I understand, there's an issue of moving things away from Windows specific libraries is my understanding, but that it is doable. We'll be exploring other operating system options once refactoring is finished. No real timeline. Everything else after that's going to have to just kind of be, we'll take it as it comes.
Right. So we want it for Linux. The rest, far future. All right. Next question. Besides what we've already talked about regarding textures and cloud distribution, What are some other ways the climate model could be used to plug into existing space engine systems or create new ones?
Um,
Synchronized.
That was in sync.
Hmm.
I don't really understand the question.
So the way I interpret the question is with this extra information from the climate model, pressures,
Ah,
temperatures throughout the atmosphere, how can we? Oh, sorry, my screen just went dark and I thought my computer turned off. How can we make other changes to the game? And the one we've sort of
well,
already discussed is clouds, potentially cloud layers, different cloud compositions.
climate model is already integrated into ships physics, aerodynamic physics, because it provides a perfect pressure density and temperature values, which are used in the physics code.
Already in physics code, definitely going to be used for clouds in the future.
Yeah,
Yes.
I think a lot of possibilities will open up. Let me rephrase
Snow,
this.
water, ice.
Yes. Right now, because surfaces are static, we could
Yeah,
use this
we can.
information to make like a nice looking texture, but maybe in the future, if surfaces and textures are a little more
There are
dynamic.
yeah,
Yeah. Sorry, go ahead.
there are two problems. First is terrains are static, terrains and clouds. We can't animate terrain textures, so we can't make a animated snow layer which changes over time over planet's year. And the second, we could adjust the current generation to make a snow level, for example, using some average temperature from a climate model. But this will change how planets look and generate, and this will break existing locations for all users. So such significant changes are delayed for the next version, like 0991 or maybe 1.1.
Yeah, we know you guys love your planets. You all have your favorites. The last thing we want to do is break them all for you.
Yes, the whole universe will be completely new in the next major update.
All right. Speaking of planets, next question. Any plans to enhance or overhaul the current version of the star map, or is it considered feature complete for now?
The star map, if it's about the star catalog, then yes, definitely our plans is to integrate the Gaia catalog. It could provide us some few 100 million stars with a complete three-dimensional positions.
I'm not sure that's what the question was about. This is referring to one of the viewing options in game, like how you view the solar system. Is that right?
Yeah, I think it's the star browser is what they're asking about.
The star browser, or
Yeah.
The star map, no, the map
Yeah.
mode. Well,
Map
oh,
mode.
map
I
mode.
gue- my map mode is a feature complete, I guess. One thing which I would like to add is it displays the places user visited or added to bookmarks in the map. It could be useful.
That would be cool. Like a flag showing where you've been before.
Yeah.
Okay, thank you. Okay, up next, will custom planets be able to be transferred from 990 to 991, or at least some of the code?
Custom planets. If we're using textures or maps from drive, of course, it could be moved. But if we will use only procedural terrain, when physical properties like orbit position, mass, whatever, will stay the same, of course. But terrain generation will be completely different because we will make a lot of changes.
The next couple of questions, I feel I can predict what the answers will be, but I'll ask them regardless. Are there any plans for volumetric galaxies? The current models appear to be quite outdated.
wait, galaxies are already volumetric. And also, yes, actually, Simeon, one of our programmers, working on a completely new code for generating galaxies. Space Engine will have unique galaxy models for every galaxy in the universe, and not not like in the current version when we have few dozen of models which are used everywhere. So all galaxies will be unique and more nicely looking, but we'll still using the sprite system the same as now.
The preliminary stuff that Sohyu has shown us is stunning. It is beautiful.
Yeah. So for clarity on that, because there was a spoiler hidden in there. That is currently not volumetric galaxies, because as Vladimir said, they're already volumetric, but improved galaxies are currently being developed, and you can expect that coming in the unironic soon TM future.
Soon registered trademark.
Actually soon. Yes, soon registered trademark. Exactly. The other soon.
All right. Up next, will there be more features on planet surfaces, such as rocks and three-dimensional grass?
Yes.
Yes.
Because as was stated in a Space Engine to do 10 years ago, everything that exists in space will be implemented in Space Engine if it's possible. Volumetric rocks and gas is possible, as we can see in our games. So I will be in Space Engine soon.
Yeah.
TM.
He said it, folks. There it is. Volumetric rocks and other features on planets, though, they are on the roadmap after Vulcan. The part of this, though, is also we would like to improve some additional things as well. So, for example, the tiling and textures on planets and things like we'd like to add decals, right? So when you look down at the surface of a planet, for example, it would be nice to see some more interesting features on the ground, right? And other things as well, like, you know, we don't have vegetation on planets that have life, but it would be nice to see that eventually coming up as well. That is going to be a much more difficult thing to implement. But yeah, that's all going to have to be post Vulcan. But it's going to be part of a larger project.
More going into the post Vulcan world.
It opens up a lot, honestly. Going from, I mean, as I mentioned earlier, OpenGL is depreciated, but Vulcan was specifically designed to be better at particular things and to make things like volumetrics easier to do. So switching over to Vulcan really does, it's a game changer.
All right, up next. I've already touched on this, but are there any plans on improving the star browser, as in providing more parameters to specify or optimizing the way objects are found?
Yes, I would like to change the algorithm that scans the stars, make it asynchronous, so you will have no lag when start searching. But adding more parameters, this interface is already quite overloaded with controls. We should think of a better way to do this. But I guess the best possible way you will not like it, because the best way to do a request to a database is like a code. You have to learn how to code database requests, and this is not what we want in a game.
Star browser SQL will update.
Yeah, kind of. I think it's better to keep it visual, but of course it will have a limited number of parameters to search. So
Thank you. Right. Figuring out how to word this one.
I like the idea of every person who wants to use Space Engine having to learn SQL. Evil.
Has to be a coder. All right. I'm going to ask this one verbatim. It would be interesting to be able to see the temperature or pressure graphs and 2D distributions as the one shown in the article for the weather forecast graphs. Is this a planned feature?
I would love that. Throughout this project, there was a lot of scope creep. So that is a term to say, you design a project one way and it keeps getting bigger. And if you don't limit it, it will never end. So again, this is step one. I did make these lovely plots to show you all like a visual representation of the climate model in the article, just to kind of help understand what's going on there. I isolated the climate model and duplicated it in Python and used Python to make those nice plots. So in the future, it would be great on the climate tab if you could have like, a little view of like a sphere of the planet and see the temperatures, day sides, night sides, etc. all together. I don't want to promise it, but let me just say in the context of like this first version of the climate model, like we had to stop somewhere. Otherwise it never would have ended.
I also should note that the climate model does not simulate a weather pattern. So you will on a perfectly flat planet, you will see perfectly flat graph. Like if you talking about a map with a temperature coded with color, you will see simply uniform rectangle. Of course, it will vary with a day and night side and with a terrain, but it will not show weather effects.
Yes, that's a good point. There's no weather currently implemented. Even basic things like Hadley cells, for example, that circulate heat from the equator up to the poles. This sort of thing is not implemented in the climate model. So the maps would look like, a hotter day side and a colder night side, basically fading from the color representing hot to the color representing cold. You're not going to see little storms or anything on there because those are not implemented in the current version of the climate model.
Thank you very much. Up next, from one of our own, could the class of planets change because of the climate model depending on the eccentricity of their orbit? What does that mean for the star browsers filter?
Sorry, can you
Yes.
repeat that?
Could the class of planets change because of the climate model depending on the eccentricity of their orbit? And what does that mean for the star browsers filter?
Yes, the class of planet changes if you can find some planet, make it huge eccentricity and see how it changed over time. But this was true even before the climate model. This is how classification of planets work in Space Engine. Regarding the second part of question, Star Browser still uses the old way to determine class because we can't integrate a climate model into a solar system generation stage because it will change how the planets generate. It will change the whole universe, all planets, all procedural planets. So we delayed this work for the next major update.
Yes.
But the new climate model is quite close to the old one because the main influence is light from the star and the planet albedo. So values returned by old model and new model are quite similar. So you may expect that if planets have like a cool class or warm class, and you want to find warm planets in Star Browser, it will most likely return warm planets with a new climate model.
All right, moving right along.
That we
Go ahead.
we do recognize this little discrepancy. Again, this is a choice made in effort to preserve the current universe, because we don't want to change the universe and the procedural generation yet. That's in another down the road. We'll make that update again, because as I saw in the chat here, you guys want to see different planets different stars if they're gonna be an improvement. And we want to do that for you, but not with every single update. We only want to change the universe when we have to.
All right, next question. You've already made a time dilation effect for black holes. Are there any plans for time dilation effects for solar systems or galaxies? Zooming out of a galaxy and watching it rotate would be nice.
Which is impossible right now because galaxies as a planet's surface are static. We're not animated. You would ask to implement animated galaxy with rotation, but it's it could be faked somehow, like simply making animated models. It's impossible, of course, to simulate movement of billions of stars on UPC. It will be fake. Maybe in future. But it's in quite distant future, I guess. Regarding time dilation for solar systems, if you're talking about light travel delay, this is on a to-do list. Yes, it will be needed for professional version, I guess, because you can't plan observation of Jupiter satellites without taking into account light travel delay, because from Jupiter to Earth it takes about 1 hour, and Jupiter moons get shifted significantly in 1 hour.
Possibly for pro version. If
Side
I
note,
heard you
that's very
correctly.
cool.
All right, up next. Are there any plans for a modding API more than just object configurations?
Yes, this is possible. I can't tell right now because we're in the middle of a refactoring. But with a new, more clean code, it could be more easy to add new software modules to the code base. Probably we can create some API. It probably would be needed for a professional version anyway. So.
All right. Is work on supernova explosions still ongoing? I saw a trailer a few years ago that showcased an early version of a supernova.
Yeah, well, it was just a demonstration what a remarched Nebula supports animation. But Supernova is not only animated Nebula model, it's a lot of other things. You must think about how to merge the star model with a expanding Nebula model, what to do with planets, how to destroy them. All this must be animated. Also, Supernova must become a light source for other solar systems located nearby. So it's a lot of changes in the code, a lot of development effort. Because we are not like to release unfinished features. If we say that this animated Nebula supernova, it will be unfinished feature because it will not eliminate over planets in our systems. It will not have animation of evaporation and destruction of planets in that system and stuff like that. So it's hard.
It would be very difficult. All right, next question. Will the jets ejected by quasars be visible from outside the host active galaxy?
Ooh, that's hard.
Yeah, that's
we
also
we
hard,
talked
but-
about this last year, Vova.
Yeah, what jets should probably be part of the galaxy model, and the new system which Simeon develops actually enables this. So we could probably make a models with jets, but this should be integrated into a procedural generator somehow. And also the question is how to merge them with a black hole model which is rendered by a completely different system.
Great. Next question that I saw star marked. Will black holes in the future have animations where, in binary systems, they slowly consume their neighboring star?
That's similar to the supernova thing about, how do we determine
Yes.
destroying different objects?
And also it could be possible, but we need to hire this guy back who implemented black holes, because it would require
won't be doing that.
what star. It would require what star which is consumed by black hole could be the part of the same shader which renders the black hole using ray tracing. So the first we must implement ray tracer stars actually, and in the same way as a black hole ray tracer works. So we could measure them in a single pass.
Right. Moving right along. Are there any applications or games using Space Engine as a base right now?
Yes, we have the overview on Steam, but it's a VR only, like a VR experience.
Gotcha. So one VR thing.
I will make a link. We can give a link.
Great. So yes, one thing. Link is incoming for that. I'm gonna, if you're good with it, Vladimir, I'm gonna go ahead and ask the next question.
Yes.
All right. Will supermassive black hole binaries ever be added?
It's the same question as about black hole and star binary. It requires change of the shader. Well, we can add like a fake binary black holes, but they will be rendered independently, and sometimes you will have visual artifacts when one become in front of another. If black holes are quite far from each other, yes, it will work. But if they are really close together, well, like form interaction accretion disk, they must be rendered in the single shader which supports binary black hole and a very complex accretion disk, by the way. It's another very complex physics how to simulate properly a complex accretion disk.
All right. Will we ever get options for filters that allow the camera to simulate other electromagnetic radiation?
Yeah, it was asked. Literally, this is asked every time, and we don't have a plan for this right now because it's hard. You have to find somewhere infrared maps for Earth, for example, for Jupiter. It's possible to do, but it's a lot of effort.
So there's something in the field of astronomy, we call it the spectral energy distribution, and it tells you how much light is an object giving off at each wavelength. So we would need a huge catalog of these spectral energy distributions, or SEDs, to know what sort of light different objects are giving off at different wavelengths. It would be a large undertaking.
Are there plans to improve orbital dynamics in procedural star systems? I've seen a large number of incredibly unstable orbits, such as separate planets reaching within a few thousand kilometers of each other.
Well, such orbits must be stable because solar system generator uses a lot of checks. It generates planets only in stable configuration. I believe so. But yes, we have a plan to completely change how procedural star system generators from a simple randomish generator to kind of a low resolution modeling of accretion disk and accretion process. So they should be more interesting. Resonances also exist. They're hard to find because the most part of code was developed before For example, before dense resonant exoplanet systems was discovered. So resonances are more common among moons, procedural moons, than among procedural planets. But this will be changed in a new updated code.
I'll also answer there was another question that's been brought up a couple of times in the chat there, and I see another answer's already been given to it. Regarding game development. So I think it's safe to say that we are planning to both continue developing Space Engine for the foreseeable future, and also eventually develop other programs. Developing games. Having worked in video games previously myself, this is something that I would not actually even want to make a comment on, except to say that developing games is a very, very different thing from what Space Engine currently is. I've seen that firsthand. Our senior programmer, Peter, has over 30 years making video games, some of them very well known, and he's also remarked on it as well. Space Engine is a very different beast, and this company is very, very different. So it's something that it seems like it's going to be a very clear, very easy thing to answer. You know, will you do this? Will you not do this? It's more complicated than that. And I think we're going to have to take that kind of step by step. But I do want to give an answer to it, even though I know that's not really a good concrete answer. The answer that was given there is correct. It is something that we are thinking about. But can we do it? Will we do it? When will we do it? Those are all things that we can't answer right now. But it's a good question.
All right. This next question is a little bit beyond my understanding, but I will try my best to interpret it. Is it possible to update the existing stellar model, which often has some errors, like 180M red supergiants, and it can be calculated much more luminosity optical than luminosity volumetric, and always generate too fast rotation speeds for a supergiant?
You're talking about errors in existing star catalog. I hope will be completely eliminated when we move to Gaia.
Right.
It will require change of how stars are handled in Space Engine, because right now they are based on stellar class. But Gaia catalog does not provide stellar class. It provides only position in space and apparent magnitude and color. Everything else must be computed from this data, including stellar class. And this will, I guess, fix these problems. Procedural star generator will also be upgraded. It will actually using statistics from a Gaia catalog. When we start working on it, we can build some graphs with statistics and adjust the procedural generator to generate more realistic galaxies.
All right. And I will say we're starting to run out of time. I have 2 more questions queued up, and then I think we'll move to wrap up. So moving on to our first to last question. Are there any plans to animate star surfaces?
Yes, stars will be volumetric. When we implement clouds, volumetric clouds, implementing volumetric stars, I guess, will be much more easy.
Gotcha.
Actually, the most complex thing will be volumetric brown dwarfs, because they are stars and planets at the same time.
Anecdote. In grad school, every time I went to a conference and they tried to do icebreakers, they would organize people by, the objects they studied, planets, stars, galaxies. And I would always just put a chair in between stars and planets.
All right, and our final question here for the hour. I'm not sure how it relates to reality, but in images from various telescopes, hundreds of stars have their own lens flares. Will this type of camera setting be a thing for the future?
If you remember very old versions of Space Engine, all stars have this diffraction spike effects. Yeah, we are planning to add them back, but we are hard to combine with a motion blur effect, which is done by geometry shader. But yeah, it would be nice to add them back.
All right, and we only have about 1 minute left. Let's see. I don't think I see anything else that could be asked relatively quickly, so I think we can just go ahead and move on to wrap up. It sounds like, in general, most of these questions, stay tuned for the post-Vulcan era.
Yeah.
Graphics nerds will be eating well.
Well, thank you very much for moderating so well, Jonathan. And thank you, everybody, for the really, really great questions. This has been a lot of fun.
Yeah, thank you.
Yeah, thank you all for coming out. I guess this is our first big Q&A as a company, isn't it? So yeah, appreciate it. Appreciate the interest.
Mm-hmm. All right. Any closing comments from Vladimir?
Well, stay tuned. We are doing refactoring, so don't expect a lot of interesting updates. But after we're done, the speed, development speed will be very big. And unlike all previous years, we also will have a much bigger team with much more programmers than only myself. So it could be great times.
Yeah. Stay tuned for the post-Vulcan era.
Yeah, bye.
Thanks, everybody. Have a great day.
Yeah, thank you.
Thank you, everyone, for
the-
coming in.
Everybody have a good weekend. And yeah, this was fun.
Absolutely. All right. Thank you, panelists. Y'all have a good day.